Welcome to the ISVR Anechoic Chamber. This is a research facility which is designed so that any sound which is produced in the inside will propagate outwards and not reflect back in like you'd get in a normal room. The building is designed to be a box within a box, so it's isolated from the outside world, and the surface is coated on all 6 faces with nearly 8,000 fiberglass wedges. The sound, which is coming in from a source in the middle of the room, will travel in and between the wedges. The sound is then absorbed into the fiberglass. Any sound which is left over will reflect off the thick concrete wall and will then start to bounce out again. As the gap expands, the energy is dissipated, and by the time you're about half a metre away from the wall, there's very little reflection measured from the outside. We use this room for all sorts of different experiments where we don't want the room to make an effect on the measurements that we're taking. One of the experiments that we can do is by using a wind tunnel within the anechoic chamber. The way we do that is by removing the wedges from this side of the wall and over on the other side. And we can roll in a piece of equipment which will blow conditioned flat air through here. There'll be an open section where we can place something like a model of aircraft landing gear, or something that we want to measure the sound which is produced off a trailing edge. Then the air will be extracted out through this direction. As well as being used by industrial clients with ISVR consulting, this room is also used by students for project work. In the second year, acoustic engineering students will complete a loudspeaker design project where they'll design and then manufacture and then test a loudspeaker. They'll bring it into this room and test it by measuring its response with a microphone. And we use this room so that the effect of the room doesn't corrupt those measurements. As well as the walls and ceiling being covered in wedges, the floor is also designed to be absorbent. So beneath this layer of metal grid, there is a floor of wedges, and this metal grid can be removed in sections so that the reflections from the floor don't make any difference. We can also do what's called a hemi-anechoic measurement, where we place a reflecting floor over this metal grid, and this will represent the conditions like we have on a road, where there'll be a reflection from the tarmac, but not any reflections from the outside. So we can do vehicle measurements in this space as well.